Ladies and gentlemen, this is Omega, and welcome to a different type of video. So I have something I'm going to be doing this episode, and that is I'm going to start some 3D print stuff. So I'm getting a 3D printer soon, and I want to make some stuff, and I want to start with something cool. So I'll show you guys the two tools I'm using, kind of the basics of how to use them, and then some of the useful websites I've found. So, a basic rundown of what we're trying to make. Let's start with that. Paint. Open that up. Switch my monitor over. Okay, so first things first. There is a platform. Right? Platform. Okay? Platform has 3 raised pegs on it. Okay? Each of these pegs is going to have some gears on them. So, I have to make some parts in this episode, and then I have to do some other stuff. But the general basis is I'm going to have a small gear directly driving a larger gear. Then I'm going to... Well, let's start this up here. So, we start small gear that drives a larger gear. Okay? Larger gear, bam. So that right there, this tiny one, it takes way less force to go a full rotation on this small one. So, you go one full rotation on this, since that's directly driving this. Oh God, I don't remember how it works. We don't want to start with a small one. We want to start with just a big one. So we remove that. And the reason for that is we get more torque conversion. So basically, if what I want to set up is called a powertrain. The general basis, you have a big gear that drives a smaller gear. This smaller gear has 20 teeth. This big gear has 10 teeth. Starting out, that's very basic. What that'll do is every full turn... Well, no, you have to do... Oh God, is it big or small? ChatGPT! In a 1 to 4 gear ratio, which gear has more teeth, comma, big or small? Also, what's a funny example? Also, what's funny? Quick, someone tell me something funny. I don't know. Let's start with that. The larger gear has more teeth. So the larger gear, here we go. So what that means now, let me get this as a 6-sided shape. So if the big one has 40 teeth, the little one has 10 teeth. Every full rotation of the big gear is 4 rotations of that small one. So this small one is turning faster. And then we directly have that small one giving power to another big one, which turns another small one faster, which directly gives power to another big one. And that is 1, 2, 3 torque conversions. So we do once more, and that's 4 torque conversions. Okay? Now, down in the base of the shape, here's the upper platform. Our 3 pegs. And our gears, right? So, I need one more. Shit. And right here is a hand crank that powers it all off one big gear. So what this means is from here to here, that is 1 torque conversion. So any amount of force you put into this is turned into 4 times here, which directly runs that power straight down, which repeats the same process again. That's 4 times. So now we are at times 4 times 4. Then we run the same thing one more time. That's times 4. So, what that means is, calculator, if we put 10 pounds of force into it, after the first turn, that becomes 40. After the second turn, that becomes 400. After the third turn, I did that wrong. Okay, 10 times 4 equals 40 times 4 equals 160. So, first turn, 10 to 40. 40 to 160. 160 to 640. Effectively meaning we've gone from 10 pounds of torque up to 640 pounds of torque. But that's not becoming straight torque. Instead, my torque is slowly... Let me go with something else to explain it. So, my torque is slowly reducing, and instead the speed is increasing by a lot. Because when it relays the force, it loses a little bit of strength in between each step. Okay? Now, once we get down below the base, this gear actually needs to be a 45 beveled gear. Huh? How do I do it? How do I do it? Okay, anyways. That needs to be 45 beveled. And what that's going to do is that's going to run its power at a 45. God damn it. Is this really the only... Okay. Here's what I'll do. I'll use this. So, that's 45 and that's 45. Now, that will run its power... bitch. That will run its power to another gear directly down, which is also 45. Okay? Right? You feeling me? You sticking with me so far? And what that's going to do is that will put a 90-degree turn. So it'll turn it from horizontal torque into vertical. Then I'm going to repeat this process again and run it through one more 45 gear. And then it's going to directly drive a gear shaft on a small engine. So what I'm planning is I turn this little crank and this engine is just going fucking nuts. Okay? But also, I want to make a drill attachment for this because that's fucking hilarious. So, let's get into designing the basics. The tools I'm going to be using for this, let's go back over here, are 1, Depending on what I have to do, I use SelfCAD for creating my 3D models. Then I use Lychee Slicer, which is a free open source 3D print software. I use that to convert my 3D projects into a direct object. However, that's what I have been doing. However, I had a different thought. So, I made this early this morning. Ignore that gear, that was an old part. I made this. This is the basics for my cage. All 3 cylinders are going to fit inside of this. And that's the basics of it, right? So I had a thought. And that's where these websites I have come in. Coming over here, stlgears.com. This is a super useful website where I can create the parts and then import them as a custom 3D gear. So, here's something interesting. All the beneficials of healing gear, but eliminating the axial thrust. Spur gills are simple. Internals, internal double helix, internal helix. These are all the basic types of gears we can make. There's also advanced objects, such as internals and spurs. So if I start this internal, this is, oh god, fuck, that's all in millimeters. Oh no. That's fine, I can get a converter. Here we go, perfect. From inch to millimeter. So, if I type in 10 inches, 10 inches is 256 millimeters. 8 inches is 203.2, which if you'll notice, if you come over here to my 3D model, this side is exactly, it's exactly half, this is half an inch thick, half an inch wide, and this is 9 inches tall. So in total, this frame, that's not right. This frame is half an inch plus 9. This frame is 10 inches tall. Actually, no, because that is on the same level as these. So I believe it's actually 9.5 inches total. So let's get into my SelfCAD. I have a completed designed model. Where is it? Redo that. This is the wrong project. Right here. This is the basis of the top. So, if you look at this, this is what I'm talking about by a powertrain. This top has a handle. You turn this handle. It spins this gear, which directly drives this large gear. However, in later versions, I'm going to just remove that top gear entirely. Every rotation of this gear is 4 of this gear, which means every rotation of this gear is 4 of this gear. Every rotation from this is 4 of this, which means 4 of this. So, every turn of this is 16 turns of this. Every turn of this is 64 turns of this. Every turn of this is, God, calculator. 1 turn times 4. That goes right there. 4 turns times 4. That's that second one. 16 turns times 4. 64. Then you times 4 again. 1 turn of this is 1, 2, 3, 4, 5. One more. One turn of this results in 1,000 turns of this bottom one, theoretically. And that's going to be driving an engine that's just hammering away and going fucking nuts. So, with that being said, let's go over here. Let's pull our measurements. This is exactly 1/2 inch thick, 1/2 inch thick, 8.5 inches long. Each of these 3 rods are. Now, I'm curious, if I pull Lychee Slicer up, does this use, if I go primitives, cylinder, and I go, what are the dimensions of that? Negative 0.58 minus 0.58 0.3. Actually, I should go 0. Oh, fuck. That, no, I'm doing this wrong. That cylinder I just added. Objects. Cylinder. First, let's scale this up so we can actually see the thing. Okay, now we have a cylinder. If I type in here, I want to go to a certain coordinate. First, we center it. Fuck. Inches. The center is 0, 0. So theoretically, step 1 is get the gears in here and see how they compare to our actual cage. So, let's go do that. First thing, before we can get those gears, is I need a new project. Which I have one right here. So, what I need to do is first come up with a design. Back to paint. If I start, okay, cylinder. Is there a cylinder tool? I need a cylinder tool. Okay, well, I'll do this first. There we go. Okay. Let's go dark red first. So, the way this has to work is we have to have a solid gear. That is the outside teeth. This is the inside hole. Okay? We have to get power from there into here. So what I did before is I had a solution. I would take, where did they go? I had both gears in the same one, didn't I? Yeah, right here. So I had slots in the big gear, and then in the small gear I had pins that came out the bottom. And that works pretty well, but now that we are working with actual gear parts, instead I can do a direct drive transfer. So I can have a secondary smaller gear as the inside of my big gear and have that same gear as part of the small one, so it directly transfers the power, no pins that can break, maximum surface area, no lacking. So let's get into designing that. Parts we're gonna need. Oh. no matter what I do here, it doesn't matter how many teeth there are, it will always be exact power transfer. So, number of teeth, let's start with, let me go back to the drawing boards. This entire system, we have our 3 rods. These rods are going to be a total of 5 inches apart. So, every one of these has to match 5 inches. Okay. Now let me grab this. So, what I'm thinking, no. Right there. And right there, right? This one needs to be roughly 3.5 inches. This one needs to be 1.5 inches. Okay? So, factor onto that an extra 1/4 inch. That becomes 3 3/4 inches. GPT! GPT! Quick, GPT! Help. 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 OpenAI, help. Hi, hi. I have a circle with a 3.75 inch radius. Yes.
I love you. I will. You be careful.
Let's go instead. I have a circle with a 3.75. First things first. 3.75 times 2. That's 7.5 fucking inches. I have a circle with a 7.5 inch diameter, comma. There is a 1/2 inch hole in the middle, comma. What
See about them, they don't have fun time.
are the sizes?
Do you want to go to your mom's with me?
No.
See how the car's doing? I still want you to ride with that boy in the morning. Okay? Did you hear me?
Yeah. Bigger circle. That is left.
You want to go for a ride? Let me take you. All right.
That doesn't help me. Circle with hole in it. Dimensions. Here we go. Damn it. Oh, I'm a fucking idiot. Okay. So then this is 1 inch. This is half an inch. This is 7.5 inches. So 7.5. 7 divided by 2. These are each 3.5 inches. Okay, here we go. Number of teeth. Let's start with 12. Module. Radial thickness. What does that mean? Okay, module. It is that millimeters? Millimeters. Okay, so it is 3.5 inches to millimeters. 3.5, it's 88.9. Okay, 88. Oh no, wait a minute. 88? Can it not go above 10? Oh, fuck. Ah. Oh, wait a minute. This is a tiny little part. That's fine. This is an internal gear. It's got 10. Let's go with 15 hooked teeth. Okay. Pressure angle. Normally 20 or 25. Let's go with 25%. Radial thickness. So this is how thick the tooth connecting it is going to be and how thick it is in reference. So, larger model equals larger teeth, bigger gear. I need like, this is 3.5. This smaller gear is 1.5 inches. So, take out 1/2 inch. That leaves me 1 inch to work with. What is 1 inch to millimeters? 1. I can't do that. Shit! I can only do single digit millimeters. So let's do... How big does it go? Okay, what is 10 millimeters? That is 3/8 of an inch. Perfect. Perfect. Radial thickness. So the tooth connecting it is also going to be 10 millimeters. Let's see if we can't import that into CAD. Import, downloads, this, open. No meshes found. Shit. Okay, let's try that over in Lychee then. Wait a minute. Show it in folder. What kind of file are you? DXF. Okay. I need to find a website. Okay, here we go. So select file, recent download, this one, open. Total file, 183.5 kilobytes. Convert that to a zip file. Now if I come in here to CAD and I import, where did that save to? Did it save to? File name. Right. Import. Documents does not need to be in cage. Here we go. Easy zip internal. This is personal and documents. We're looking for easy zip internal. No objects imported. Okay. What type of file can self-CAD import? I need to figure this out. Did we go back to GPT? Okay, wait a minute. Hey, can I look at your other options? Right now I have DXF. DXF 2. Let's try OBJ. Convert RAR to DXF. So, internal spur. Open. Convert. What? What? You. Something's broke. Okay. You. Open. You. Convert. Uploaded file is not supported. Bullshit. Bullshit. DXF. What is a DXF file? GIMP. Why did I open that with GIMP? GIMP fucking sucks. I'm going back to the basics. What is a DXF file? It's a vector format when used for sharing 2D and 3D designs between different CAD formats. Okay. Next. DXF2 CAD file. Let's try this. Okay, we have a different kind of file now. Can we import that one? OBJ. Open. Additional files required. Son of bitches. Hey! No! That isn't what it's supposed to be at all. Bullshit. Oh, that was a different type of file generator. Okay, let's see about this. Internal double helix. So, outer diameter, let's start with that. It's going to be 1 inch. 25.4 millimeters. Okay. Gear length. What does that mean? Pressure angle. This needs to be, let's start with 25. Helix angle. I believe that is how they turn. Okay, let's start. Let's start with 8.5 millimeters. Number of teeth, 15. Helix angle. Oh God. So the helix angle is how steep these teeth bite. And I want them to bite pretty shallow. Does this have a protractor tool? No. But I can make my own. How do I do it? Okay, circle. It's not going to be a perfect circle. Damn it. Here's what I do. Straight line. 2566. One pixel. Okay. Now I come up here. One pixel. Come over here. 1 pixel. Okay. Now 45. That is about a 45. So we want to go 22.5 degrees. 22.5. Okay. So, one. It should be 25.4. That's my entire... Oh, you know what? I understand. Gear length. What is gear length? Okay, how this way the gear is. It is 1 inch, which is 25.4. Why is that not okay? Huh? Let's try 38. Help. Help. How do I do it? What do you want from me? Inch and a half. Maybe I bump this up to 10 millimeters. And again, this is 25.4 millimeters. Okay, I'm not doing the double helix. I'm just going to do spur gears then. So, I need first my small gear, which is the basis of everything. It's going to have 10 teeth. The teeth need to be try. If it's 1.5 inches thick, half an inch of tooth would be fine. So that's 12.7. Okay. 10 teeth. Pressure angle. 25. 25. Gear length. 25.4. 10 teeth. That's the correct thing. Profile shift. Oh, fuck me. What are you? What are you? Profile shifting, where the cutter's depth inward or outward, resulting in a subtle appearance to the tooth of the gear. No, I don't have that. Profile shift 0. Hole type. Hollowed. Okay. Circular. Oh, here we go. With a 1/2 inch. 12.7 millimeter. Wait a minute. Hold on. Hold on. Hold on. I think I fucked something up. So, where's my measuring tool? That is about 1 inch across on the inside and about 6 inches across on the outside. So this is what? How do I define that? Okay. What are you? Position shift. Gear geometry. Show more this. Here we go. So, The module is a crucial factor in gear design as it determines the overall size, represented by the pitch radius and the tip of the tooth. So that is a larger gear module will result in bigger teeth, bigger gear, stronger teeth. Okay. That is not the feature I was looking at. Just curious, what would this same thing look like with 20 teeth? It's 1 thick, 11 wide, and 11 long. So if I instead... Are you millimeters or inches? Huh? If I just come in here, that is 6 inches. This is 12. Or no, this is 11 wide and 11 tall. If I want to go... Oh God, what was it? 3.5 and 3.5 and 3.5. We have our first gear. So that is the drive shank mechanism. Next, we need a 20-tooth spur gear. Internal spur gear. It needs 20 teeth. Oh, what did I do up here? 12.7 on that. Pressure angle 25 should be fine. Gear length 25.4. Outer diameter. So this is going to be half of our big gear. So let's go 2.5 inches. 63.5 millimeters. 63.5. Why are you flashing at me? Do you not like decimals? Is that it? Can you please make my part? Oh my God. Oh my my god, why don't you work? My outside diameter is 72 millimeters. My inside diameter does not appear to exist. 20 teeth in that circle. Module. Fuck if I know. What if we bump this up to like 20 millimeters? No? 30. No? 40. No? Why does it not want this? It did it at 30 millimeters with a 0.3 millimeter. What does that look like? So I know what to tweak. Okay, file, import. This one. Oh my god, it's itty bitty. What? That's so fucking cute. So you are 1 inch and 1/8. Okay, let's do millimeter to inches then. If I go 35, 36, 37, 38, 39. Okay, 38 millimeters. If I go 38 millimeters and internal thickness 1, 2, 5, 6, 7. Okay, we'll go 6 millimeters on the module. 6. And that don't work now. Why don't you work? Okay. It's fine. It's fucking fine. What if I swap the number of teeth down? What if I go... Oh, wait a minute. I'm an idiot. The way that's calculated... is we have this circle and this is the outside of our teeth. Okay? So the module size is this right here. That is module size. So if I need that to be 3/8 of an inch, I need half of 3/8 of an inch. Oh my god. Okay, 3 divided by 8. 0.375 of 1 inch. So that is 9.5 millimeters. That can't be right. Hold on, let's start with some basics. What is 1 millimeter? That. And what do we need? 0.3. 4. 5. Let's try 5 on this. No. 3. Okay, it would do 3. What does that look like? Oh. Okay. Here we go. So, then if I'm understanding that right, what we were setting up there is this. Yes, this is 3/8 of an inch. So it's from the back to the tip of the tooth. Okay. We're getting somewhere. I don't know where we're getting, but I'm understanding gears. So, it would do 3 millimeters, which is 3/8 of an inch. If I wanted to do 0.5, if I want half an inch total, that is 12.7 total. So I need 6.3. But that needs to be bigger. So what about 2? What does 2 look like? File, import, newest. 2. So 2 millimeter is smaller internal hole than 3. Interesting. I think I'm going to go with the 3 millimeter. So let's delete this. Next. Let's move you over and get you in the center of the field. So your total size right now is 1.5 inches, tip to tip. I need a gear U. You have, cool, I want to go solid. You have 10 teeth. So if I move you over here, and I set your size down to 1.5 by 1.5. If I'm understanding correctly, you are now the same total size as this. So what I have to do, how thick is this? What? No. .1 of an inch. So theoretically, if I go to U and I take U down to 1.4 and 1.4 size, and I rotate you, now you should fit almost flawlessly into the middle of this. Yes. That is the basics of our drive. Okay. Let's delete this inset spur. Now, this needs to be 2 inches thick. And let's move you right there. Okay. Can I take all of this and rotate 90 degrees by chance? let's first move you to 0, 0, and 1. Okay. Now, our Y value is rotating around the Y-axis. X should rotate around the Z-axis, which is which way? Okay. So if I rotate this 90. Yes. Bada bing. It's fucked up. We'd be better off just fucking. Now that's pretty straight. Okay, next. That's not even close to straight. Fuck, how do I center it? Move center, please. Zero, 0, 0. Up. Rotate. Oh, God. That's pretty close, at least. If I put a cube in, I make it 1 wide, 1 deep, 3 tall. Check. That object is perfectly straight. If I move it right next, and I rotate it, that gives me a reference. So, X right there will be perfectly straight. Okay, let's get this out of here. Next, we have to separate our meshes. So, we take that, and that has to go. I need to copy this, move it up, and change the dimensions. It needs to be 1.5 and 1.5. Okay. And that is just you. Now, this one, I need to scale. Just generally down. And it needs to be, I can go over here to utilities. It needs to be 0.4 inches. This one, scale, it needs to be 0.4 by 0.5. 4 by 1. Okay. Next, I need to take this, change you down to 1 also. Now, if I just take everything and center on 0, 0. Okay. Next, I select this and this. No. First, select this. I copy this because I'm going to need a second one. Then I take this. I raise it up to be level. I make sure you're 1 and you are 1. Okay, I select this and this. I stitch and scoop. I remove the difference of this one. So, then I grab this and move it out of there. That results in something being wrong, basically. Undo, 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 undo. Now they're back separate again. I remember how to do this. I remember what I'm doing wrong. I take this little gear. I take our internal shank. Move it out of the way. I create a cylinder with the same dimensions as this internal shank. So, what are your dimensions? Of just this. 0.4, 0.4, and 1. So 0.4, 0.4, and 1. Okay. Now you are centered on 0, 0, so I move you straight up into that. Yes. Now I select cylinder and gear, stitch and scoop, subtractive. I cut the cylinder out of the middle, so I get a larger hole. Done. And then this fits right in that hole. And just like that, I select you and you, Tools, combine, merge. So, if I do that, you are now one solid object. Jesus Christ, we're 1 hour in and we have a single gear. I gotta go eat some food. BRB. I got food. Okay. So. I got the basics of this down. I'm realizing we did this all wrong. So. Theoretically, if I scale this down to 0.4 and 0.4, right? You are now 2 inches tall, and I scale this up to 1.5 inches and 1.5 inches. Now this Right. So I did all of this backwards, and what I mean by that is this needs to be inside the big one. And the big one needs to rotate 90 degrees. So we need to cut this shape out of the big one, because the big one has to be drove by a shaft coming off of the small one. So let's undo until that merge happened. Oh fuck, that's all the undos we get? Okay. Change of plans then. File. Import. That is the 20-tooth gear. This is the 10-tooth? Yes. So what I need to do, actually, let me see something. Gear, it needs 10 teeth. Pressure angle. Oh, wait, we can actually see in physicality what pressure angle does. So a lower pressure angle is straighter, less sharp teeth. Okay. I like 25. 10 teeth is 1 inch. Pretty smooth. Module. So this from if I go 1.5 on this, save. Now we have, okay, 1.5, 1.5, we have an 1.5 by 1.5 gear. Now I need to do two things with this. I need to make my 1.5 gear 2 inches long. and then I need a 1/2 inch hole set into the center of this big gear. So, this is where things get fun. I need to set your size to 5 inches, 1.5 inches, 3.5. So you need to be 3.5 by 3.5. You need to be 1 inch thick. Okay. Now I move you to 0, 0, and 1. Okay. You are 1.5 by 1.5 by 1 gear. Perfect. So, undo, 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 undo. Perfect. Now that's the 1.5 and 1.5 by 1 gear. If I just if I select these two, and I stitch and scoop, subtract gear 1, no, gear 2, what about union? Okay, so the problem I'm having right now is this is not a solid object, right? So what I need to do is put a cylinder in here that is 1 inch by 1 inch, 1 inch tall. Done. Right there. So now if I stitch and scoop these two, union, that becomes one solid object. I need to go over here to utilities, combine. Yes. So now that is a solid object. And what I can do now is if I drag this back to 0, 0, undo. Now if I select U and U, utility, stitch and scoop, subtractive, subtract the small gear preview. Didn't fucking do anything, did it? Get it? I don't get it. Stitch and scoop difference. Subtract this one, please. Thank you. Yes, that's what I wanted. And now there's our big gear designed, and this little gear, we make this gear 2 inches long. And that fits perfectly inside. And if we turn this, it'll turn the big one in almost perfect unison. Okay. Let's trash this now. Let's get this over here. So this still has to have a 1/2 inch hole in the middle. So you need to be 1.5 by 1.5, 2 inches wide. Okay. Now, how big is the hole in you? Because that is important to know. Quarter of an inch. Okay, so what I have to do instead is select both of you, scale you up to 5. What does that look like now? That's 0.3. So, select again. Scale. Scale up again. What about now? This big one is now 7.5 inches across. The small one is now 1/2 inch hole, and its size is 3.5 inches. So, what does that do? Let's go figure that out. The general basis of this is each layer, we have 7.5 inches. And it doesn't matter because this is the drive shank. How far out does that go from the center? That's what I want to know. About 4 inches out. So this model is a total of, let's get this right. It's a total of it's 8.5 inches by 8.5 inches. Which is not going to be good enough. So I have to design a new modular base. So, if I scale you down to, how do I get to, what is 8 inches? 203.203. 203.2, right? We start with that. Oh, I got all that backwards. Okay. Now we have a generally smaller platform. So I have to this piece invisible. This piece invisible. And this piece invisible. I have to make insets and outsets so I can make 4 platforms and slot them all together. Which means 8 by 8. This now becomes a 16 by 16 grid. So, that changes things. 16 by 16. Which would mean instead our gears are going to be more towards the center, and they are 7.5, which would drive a small one here, which would drive 7.5 here, which would drive a small one here, which would drive 7.5 here. So in total, we need... Actually, I can just do this right here. Copy. Up. Okay. Right there. I don't like the pitch. I wish I could reduce the pitch. Anyways. Let's copy this again. Move it right there. So, in total, you are... dimensions. 3.7. Let's start here. From the top to the very bottom is nothing that doesn't exist. Measurements. Okay, so the longest point 12.5 inches, 13.5 inches. So this is our center point. 3.5, 3.5. Hi. See, also we have to factor in with our orientation. Is our shaft going to hit the gears? So, let me delete this cylinder. Actually, I'm finishing. I'm done. I'm done. I'm done. Let me save the changes to this. Let me close that. let me save this. Close this. Closing paint. Don't save. Now I'm going to favorite. Close that. Close this whole window. Next. Easy zip. I don't actually need you anymore. Okay, so this has been the first episode of trying to make something sick. My pizza's cold again.